Every time I see a drone show, I can't help but think, how is this possible? To me, it looks like modern witchcraft, so that's why I decided to find out how do drone shows work. The creative process for a drone show always starts with an idea. Maybe you're dreaming of an aerial dragon or a specific message written across the night sky. Whatever your vision, its realization involves specialized drone show software. This software resembles 3D programs like Blender or Cinema 4D, where you can create objects and animations in a virtual environment using vertices, the corner points that form the structure of any 3D model. For example, a simple cube has 8 of these points. However, instead of working with vertices, you work with drones. These drones, illuminated in the darkness, take the place of vertices to assume any imaginable shape in the air. Unlike 3D modeling, where you also work with edges and faces, a drone show presents a different challenge. You don't have edges or faces, only points of light. To mimic a simple shape like a cube in the air, depending on the desired size and resolution, many more than 8 drones are required. Every show design consists of 3 crucial elements. We need to know how many drones are necessary to create the shape and animation. Then we need to program the XYZ coordinates of each drone at any given time during the show in order to create the desired image. And we also need information about when the LED lights on each drone should go on, and if so, in which color. Luckily, modern drone show software allows the import of 3D models and animations. This way, existing designs created in your familiar 3D software can be transformed into a breathtaking airshow. But you can also build a whole show from scratch. There are also plugins that will allow you to create a drone show without having to leave your favorite 3D software. In the SkyBrush add-on for Blender, for example, you can create distinct key shapes or frames at different points on the timeline, such as a ball at the beginning and a cube at a later time. The software then automatically calculates the intermediate shapes and creates a smooth transition between these keyframes. This process, known as interpolation or morphing, allows the software to generate the frames in between the user-defined shapes, resulting in a seamless animation without the need to manually position each drone. You just set the start and end points, and SkyBrush handles the transformation between them. Within the drone show software, you simulate the entire show, adjusting every detail until it's perfect. But at that moment, you essentially only have a digital plan, a series of instructions on how many drones are needed, their exact locations in 3 dimensions at each moment of the show, and their color at any given time. All this data, stored in the language of computers in the form of digital code of ones and zeros, must be put to use. Software plays a crucial role, but of course, we need some hardware to bring this aerial spectacle to life. The drones, or show drones, are no ordinary quadcopters. They are designed to be lightweight and robust to ensure that they can maneuver precisely and withstand bumps and strong winds. These drones are outfitted with vibrant LED lights, capable of creating a spectrum of colors and patterns. Furthermore, precision is key in a drone show, which is why these drones come equipped with a ton of sensors to keep them exactly where they need to be. Of course, there is GPS to determine their precise location, but they are also equipped with EMUs, or inertial measurement units, which help the drone understand its orientation and movement. The EMU feeds data about the drone's speed, the angles at which it's tilting, and its direction. This information is crucial for maintaining stability and to ensure the drones fly according to their programmed patterns. Then there's also the barometric pressure sensor. This sensor helps the drone maintain a stable altitude by measuring atmospheric pressure. Since air pressure decreases with altitude, the drone can determine its height above the ground. They also have collision prevention sensors, but more on that later. Industry show drone examples include the Firefly Gen 2 that was used in this show at the anniversary celebration of the St. Pete Spear, and the Intel Shooting Stars, which were used at the Olympics and the Super Bowl. It offers a flight time of around 20 minutes and has a range of 1.5 kilometers. Fun fact, the current world record holder for the largest drone show used 5,162 drones and was performed in China by Higrade. So you programmed your show and all drones are neatly laid out on the field. But how do you transform this collection of drones into the stunning formations you had in mind? The answer lies within the control center, the beating heart of the show where everything is coordinated. A computer loaded with all essential data in the form of ones and zeros is connected to a transmitter. This data is then sent into the air as RF signals through an antenna. RF communication, similar to Wi-Fi or radio, uses electromagnetic waves called carrier waves. These waves are basically invisible light and therefore move at the speed of light. This makes them perfect for applications where any noticeable delay is unacceptable, such as drone shows. To send all the instructions to the drones wirelessly, they use a technique called modulation. This involves modifying a carrier wave to encode instructions for drones. The main types of modulation used are on-off keying, frequency modulation, and amplitude modulation. On-off keying is basically digital Morse code, transmitting binary data by switching the carrier wave on and off. The other modulation forms work in similar fashion, but by changing the amplitude or frequency. For example, a lower amplitude may signify a 0 and a higher amplitude a 1. This encoded information is sent through the air and picked up by the drone's antennas. This is an oversimplification, but a 1 could tell the drone to turn its lights on, while a 0 could mean that the drone should turn its lights off. Okay, great, so we have technology to reach the drone, but how do we give the right instructions to the right drone? This precise targeting is achieved through the use of unique identifiers, or UIDs. A UID is a unique code assigned to each drone, similar to a personal identification number, ensuring that the broadcast signals from the control system are recognized and acted upon only by the drone assigned to that specific UID. Flying over 1,000 drones next to each other can get very hectic and very messy. Imagine drone 769 and drone 775 are part of a large drone light show. An unexpected gust of wind slightly pushes drone 769 off its intended path, putting it on a potential collision course with drone 775, and all of a sudden, the show is in danger. Here's where technology steps in. The drone sensors detect that drone 769 is pushed off course and notices the increased proximity to drone 775. The control system receives data from the GPS and obstacle detection sensors. Advanced algorithms then process this data in real time. It immediately calculates alternative routes to avoid the collision. And last but not least, safety. Drone shows incorporate multiple layers of safety to ensure the well-being of both the drones and the spectators. Geofencing creates a virtual boundary around the performance area. Drones are programmed not to fly outside these predetermined boundaries to ensure that they remain within the safe and approved airspace throughout the show. Most shows also include a panic button to immediately ground all drones if necessary. This can be triggered manually by an operator or automatically by the drone systems. It is also possible to take control of each individual drone if one decides to go rogue. In summary, the key steps to a successful drone show include conceptualization, detailed design in specialized software, effective RF communication, precise identification through UIDs, rigorous collision prevention strategies, and of course, safe landing protocols. And if you found this video helpful, don't forget to like and subscribe for more content like this in the future. And I'll see you in the next one.